Hey algebra students, this is Mr. Montes, and we are back with another lesson for PHS algebra. I am currently outside, so if you hear some background noise, whether that's the wind, some birds, or maybe a dog barking, I apologize. I am outside because this is the only quiet place that I have to be able to record this video. So just had to get that out of the way. Today we are going to be talking about multiplying binomials. As the title dictates. The previous lesson from last week was adding and subtracting, so if you haven't gotten a chance to do that, I would suggest going back and doing that. There's some things that we're going to be doing in the lessons for next week. They're going to require you to know how to add and subtract like terms between two polynomials. So if you get a chance, go back and do it. It will definitely help you out in the long run. So if we're going to be talking about multiplying binomials, really we should talk about what a binomial is, or at least review it because we've already talked about it. Binomials are an algebraic expression of the sum, which is addition, or the difference, which is subtraction of two terms. Down here we have some examples. We got 5x plus 1. That is going to be known as a binomial because we got 5x, which is one term, and the number 1, which is going to be a second term. Down below that we got x squared, that's one term, and then we got 6, and that's another term. Notice that these two terms are separated by a minus, whereas above 5x and 1 were separated by a plus, so it's addition or subtraction. Off to the right we have a few more. We got negative 3x minus 2, again two terms. Negative xy, this one looks a little funny, but that's okay. That's one term there, and then we have another term over here. So each one of those is going to be a binomial because the polynomial only has two terms. Pretty easy, right? All right. Now that we got that out of the way, let's jump into the distributive property, which I think everybody has heard of. I know we covered it several times, but it's okay because sometimes, it's kind of easy to forget some of this stuff. So suppose, and let's change this to a 5. Suppose I add 5 times 6 plus 2. Now, the way that you would approach this problem would be to add 6 and 2 first because that's inside the parentheses and we always follow the order of operations, and then multiply the result by 5. But there's another way to do this, and we can do this simplify this using the distributive property. The distributive property says that I can take my 5, which is on the outside of these parentheses here, and I can distribute 5 to 6 and 5 to 2. And by distribute, what I mean is take 5 and multiply it to 6, and then add that to 5 multiplied to 2. And we're adding because we are working with a plus here. So 5 times 6 is 30, plus 5 times 2 is 10. The result is 40. So it seems like a really roundabout way of doing this problem, and it is kind of, it's not the shortcut. The shortcut would be to add 6 and 2, turn that into 8, and then multiply that to 5. But what happens is, in this scenario, we can combine 6 and 2, but there's going to be scenarios where we cannot combine them, right? So that's why we need to know this distributive property. I can give you another example using more numbers. Suppose I had 4. Let's do that in black. Suppose I had 4, and I was multiplying that to 7 plus 2 plus 3. Now again, logic dictates that I should add 7, 2, and 3 first, then multiply it to 4. But if we're going to practice using the distributive property, I'm going to go ahead and distribute the 4 to each term. So I got 4 times 7, plus 4 times 2, plus 4 times 3. 4 times 7 is 28. 4 times 2 is 8, plus 4 times 3, which is going to be 12. And if I add all of those together, I should end up with 48. Now again, it seems like a really roundabout way of approaching this problem, but that's only because I can combine 7, 2, and 3. If I couldn't combine them, if they weren't like terms, then I would be forced to use the distributive property, which is what we're going to show you next. Okay, so let's practice this with some numbers. So what if I had, let's say I had, let's see here, we have 3 times x plus 2. Notice that x and 2 are not like terms. We cannot combine them. That's as simplified as it gets for that. But what we can do is we can take this 3 and we can distribute. Right? So if I take 3 and I distribute to each term, I would end up with 3 times x plus 3 times 2. So this would end up being 3x plus 6. And I'd be done. I cannot combine 3x and 6. I can't turn it into one number because those two terms are not alike. So I have a monomial, that's this right here, multiplied to a binomial, which is this right here, and the result ended up being a binomial. Now, why would we do this? Well, there's certain scenarios where we're going to want to combine some things, and the only way we can combine things is going to be to use the distributive property and then use some addition or subtraction. So we need to get this part down to make sure that we can do this properly and effectively. So let's show you another example. Let's say I have 4 times x minus 3, and that's quantity. So again, distributive property. I'm going to distribute the 4 and distribute the negative 3. And you know what? I forgot to tell you guys what the instructions might be for this. They might say something like distribute. Right? They're just going to ask you to distribute. So 4 times x is going to be 4 times x. And in this case, we have a minus, and this is 4 times 3. 4 times 3. So this ends up being 4x minus 12. And you're done. So when we are distributing and we're multiplying a monomial times a binomial, we just use that distributive property. We actually end up with a binomial every single time. And if you notice, you cannot combine 4x and 12, 3x and 6. That's always going to be the case, especially since you can't combine these two up here. It's going to end up being that we can't combine these two terms down here. All right, let's make a little bit of a jump because the lesson is called multiplying binomials. So what if, let's say example here, what if we were multiplying x plus 2 times x plus 3? So what if we were multiplying a binomial by another binomial, right? So it turns out that we can actually just use the distributive property. It's just going to look a little bit different, right? So if you notice before, and it's in the red box here, I'll highlight it, we took the 3 and we multiplied it to each term in the binomial. We're actually going to do the same thing here. And I'm going to take this, except we're going to take this x plus 2 as the entire thing, and I'm going to multiply it to every piece. So I'm going to distribute the thing that's in the parentheses, this thing that I'm going to highlight right now, this piece. Right? So what is that going to look like? Well, just like I did up here, this turned into 3 times x. I got, whoops, get that out of the way. I got 3, and I multiply it to x to get 3 times x. Here I'm going to take this thing, and I am going to multiply it to x. So I would end up with x plus 2 times x. Okay, and then I would be plus, and I'm going to distribute the x plus 2 to the 3. So I'm going to end up with x plus 2 in parentheses times 3. So if I highlight this piece right here, and this piece right here, that's what was distributed. Notice that this is still x and 3, and that comes from still x and 3, and that comes from x and 3 up here, added together. So what do we do now? Well, I don't know if you can tell, but we can reuse the distributive property. So I have here x plus 2 in parentheses, and on the outside I have an x. Now it doesn't matter that the x is on the right. I know the examples I showed you were here, it was on the left. It doesn't matter. It just has to be on the outside of those parentheses being multiplied to it. So in this case, I'm going to take this x and I'm going to distribute again to here and here. So I'm going to end up with, I'm going to go all the way out here first, x times x. Remember, x times x is x times x plus x times 2, so 2 times x. And I'm going to go ahead and distribute this as well, here and here. 3 times x plus 3 times x is going to be 3 times x. And then plus 3 times 2. 3 times 2. Right? This is from the part on the right, and this is from the part on the left. So now what we're going to do is calculate x times x. Well, x times x is x squared. Plus 2 times x. Well, we're just going to write that as 2x. Plus 3 times x is just 3x. Plus 3 times 2 is going to be 6. So we're real close. We're almost done. There's only one thing you have to realize, is that these two terms are alike. They both have x's. And we can combine them. So I have x squared plus 2x and 3x. And 3x are going to combine to give me 5x. And then plus 6. And we are done. So we took two binomials, we multiplied them together, and the result ended up being a polynomial with 3 terms, which we are going to call a trinomial, right? So it turns out that if I take two binomials and multiply them together, I'm always going to end up with a trinomial.